All right, welcome back, mathematicians. Here is another example, another exciting example of a question you are going to see in regards to Pythagorean theorem. So this time we just have a word problem. So let's read what it says. It says the width of a rectangle is 4 feet and the diagonal length of the rectangle is 13 feet. Which measurement is closest to the length of this rectangle in feet? All right, so first, before we start messing with these numbers, let's identify what information it's giving us, right? So it's saying that the width of a rectangle is 4 feet. Okay, so I know I'm dealing with a rectangle, all right, and it's giving me the width, and that width is 4 feet, all right, and the diagonal length of the rectangle is 13 feet. Okay, diagonal length, all right, is 13 feet. All right. Which measurement is closest to the length of this rectangle in feet? Okay, so we want to know the length of this rectangle in feet. So the first thing, since it didn't give us an actual diagram, let's draw and create our diagram. All right, so I know I'm dealing with a rectangle, right? So hopefully we all know what rectangles look like. So here is a rectangle, and it's telling me the width of this rectangle is 4 feet. All right, so it's giving me this dimension right here. It's telling me this distance from here to here is 4 feet. And then it's giving me the diagonal length, right? Diagonal length of the rectangle is 13 feet. So diagonal, remember diagonal, I'm going from one corner to the other corner. So this distance right here, diagonal from this top corner to this bottom corner, is telling me is 13 feet. Okay. And then let's figure out what it's asking. It wants to know the measurement of the length. So it gave us the width, it gave us this diagonal. It wants to know the distance from here to here, or the length of this rectangle in feet. That's our unknown. So I'm just going to use the letter X to represent that unknown. Okay. Now, in order to find this distance, we can use the Pythagorean theorem. Okay, remember, Pythagorean theorem works with right triangles. Well, I know if I have a rectangle, right, each corner represents a right angle, okay, or a 90-degree angle. So here's my right angle right here, right? So here's my right angle in my right triangle. And so the first thing I need to do is identify which side represents my hypotenuse. So once I know where that right angle is, I can draw an arrow pointing away from my right angle. And that arrow will always point to my hypotenuse. Okay. Now remember, your hypotenuse is the longest side in your right triangle. So if I know the hypotenuse, or the longest side in this right triangle, is 13 feet, I know that this distance right here cannot be more than 13 feet, because the longest side, or my hypotenuse, they're telling me is 13 feet. So just by knowing that, before I've done any math, if I look at my answer choices, any answer choice that is bigger than 13, I can get rid of. Okay, so if I look at answer choice G, it's saying 17 feet. Well, I know this distance cannot be 17 feet because it can't be bigger than my hypotenuse. My hypotenuse is the longest side. Okay, so it can't be 17, and it also can't be 13.6, right? Because both of those numbers are greater than or bigger than 13. So before we've done any math, I'm already down to 2 answer choices. Okay, I got a 50-50 shot. So at least if I have to guess, the chances of me getting it correct have greatly increased, right? I got a 50-50 shot now. Okay, but we don't have to guess because we know Pythagorean theorem, right? It's our best friend. So let's write our equation. A squared plus b squared equals c squared. Okay, so here's a leg. We can call this one A. Here's a leg. We can call this one B. All right, and here's my hypotenuse. Your hypotenuse is always C, okay? It's important. C is always the hypotenuse. And again, to find that, we just find our right angle and we draw an arrow pointing away from that right angle. Okay, so it gives me A, which is 4. So if I plug that into my equation, 4 squared, right? Plus, this time we don't know B, right? That's what we're solving for. So I'm going to leave that B. I don't know what B is. That's our unknown. That's what we need to solve. So plus B squared equals, but we know C. Okay, this time it gave us the hypotenuse. It said the hypotenuse was 13. So we're going to do 13 squared. All right, now let's do a little bit of math. Okay, so let's go ahead and square this 4. So 4 squared gives us 16 plus, we're going to leave that B squared because we don't know what B is yet. We can't square it if we don't know what it is. All right. But I can do 13 squared, right? So if I do 13 squared, or 13 times 13, we get 169. All right, so this is just an equation, okay? So I want to find what B is. Well, right now, I'm adding 16 to it, right? I've got this constant. Anytime we have constants, we need to get rid of those first. So this 16 is a positive 16, right? I don't see a negative sign in front of it, so it's positive. So to cancel out a positive 16, I'm going to subtract 16, okay? Whenever we're solving equations and we're canceling out, we always do the opposite. All right, that's an ugly 6. Let's get rid of that. All right, minus 16. Okay, so this is now gone. So I am left with B squared equals, and if I go to my calculator, 169 minus 16, I get 153. Okay, so 153 is what B squared is equal to. But I want to know what B is equal to. So in order to do that, I need to do the opposite of squaring a number. Well, the opposite of squaring a number, we know, is taking the square root of a number, right? So if I take the square root of B squared, that leaves me with just a single B is equal to, and if I go to my calculator and I type in the square root of 153, I get 12.36, and then it keeps going, right? So if I look which measurement is closest, if I were to round 12.36 to the nearest tenth, I would get 12.4. So our answer is H.